Welcome to Daily AI Brief, where we dive into the latest advancements at the intersection of artificial intelligence and technology. Today, we'll explore four groundbreaking innovations, from enhancing cybersecurity through autonomous threat hunting to transforming how we approach software development. These developments are set to redefine the terrain of AI applications. Cybersecurity threats are ever evolving, and staying ahead requires innovative solutions. Nebulock's latest offering, Autonomous AI Agents, aims to revolutionize the threat hunting landscape by significantly enhancing detection and response mechanisms. By leveraging AI, Nebulock addresses the traditional limitations of static and reactive security systems. Unlike conventional cybersecurity tools that rely heavily on predetermined rules, Nebulock's agents autonomously hunt for threats, sifting through data cues arising from new threat intelligence or changes within an environment. This shifts security operations from passive responses to proactive threat management. One of the standout features of Nebulock's solution is its dual functionality. Through natural language processing, NLP, these AI agents not only operate independently, but also act as co-pilots in cybersecurity investigations. For security analysts, this means a more interactive and intuitive interaction with the system, reducing manual workload and human error. As threats are detected, the agents can synthesize data into actionable insights, effectively turning cryptic data points into comprehensible strategies. Transparency is at the core of Nebulock's approach. In an industry often criticized for its opaque black box AI models, Nebulock addresses these concerns head-on by displaying the internal reasoning of its AI agents. This transparency is not just a technical feature, but a strategic one, aiming to enhance trust and align with regulatory compliance standards. Part of Nebulock's success in maintaining the effectiveness of these AI agents lies in its collaboration with Arise AI. Arise plays a crucial role in performance monitoring and evaluation, ensuring these agents perform reliably across various operational settings. Through Arise's platform, organizations can closely monitor agent performance, adjust parameters, and derive insights needed to optimize threat detection. From an implementation perspective, integrating Nebulock's AI agents into existing security frameworks may pose some challenges. Although designed to complement current infrastructures, it requires careful planning and execution. Organizations must navigate operational adjustments and potential data privacy concerns given the sensitive nature of information being processed. While specific performance metrics from Nebulock haven't been disclosed, early estimates suggest a significant reduction in time to detect threats. This increased speed and potential for improved accuracy are crucial advantages in identifying and neutralizing sophisticated cyber attacks. For companies willing to explore these possibilities, practical steps include evaluating Nebulock's AI agents within your cybersecurity environment and leveraging Ares's monitoring tools to assess performance. As threats grow more complex, the applications of AI in cybersecurity continue to expand. Nebulock's solution not only enhances the defensive posture of organizations, but also represents a shift towards a more agile, transparent, and smart cybersecurity landscape. By adopting such solutions, companies can drive substantial reductions in security risks and financial losses, while contributing to the broader evolution towards AI-driven security strategies. The Allen Institute for AI, AI2, is pushing the frontiers of coding automation with SERA, a cutting-edge family of supervised coding agents designed to handle repository-level tasks using innovative supervised training. These agents shift the paradigm from traditional methods, presenting a more cost-effective and efficient approach to coding automation that could revolutionize how organizations develop software. At the heart of SERA is the Soft Verified Generation (SVG) technique, a breakthrough approach that enables the creation of vast synthetic training trajectories from a single code base. Specifically, over 200,000 trajectories have been synthesized, showcasing the model's capability to efficiently bootstrap its training dataset. This is particularly pivotal, as generating such a multitude of trajectories traditionally demanded significant computational resources and time. The flagship model, SERA 32B, is engineered on the advanced Qwen 3 32B architecture. It stands out with impressive resolve rates, hitting 49.5% at a 32K context, and an even stronger 54.2% at a 64K context on the SWE Bench verified benchmark. These rates signify the model's robust performance in deciphering intricate coding tasks within extensive context windows, critical for handling real-world software development challenges. Financially, SERA's training methodology marks a profound leap forward. By leveraging supervised fine-tuning, the cost of training is slashed by 26 times compared to reinforcement learning techniques and 57 times against prior synthetic data methods. This dramatic cost reduction democratizes access to high-quality coding agents, allowing more organizations, regardless of their size, to integrate cutting-edge AI solutions without prohibitive financial barriers. Despite these advancements, there are trade-offs and considerations to keep in mind. SERA must still prove its mettle across diverse coding tasks and codebases. Questions linger regarding its long-term scalability and its adeptness in handling edge cases or less typical coding practices. Such limitations suggest ongoing evaluation and iteration are crucial as more feedback from real-world applications becomes available. For practitioners and researchers interested in leveraging this technology, SERA is openly accessible on platforms like Hugging Face, under the Apache 2.0 license. Practically, this model invites exploration and experimentation within diverse environments. Developers are encouraged to try training SERA with their own projects to gauge its effectiveness in their specific contexts. AI2 has ensured that SERA assimilates seamlessly with tools like Claude Code, enhancing the functionality of development environments. This integration underscores the potential for AI-driven automation to streamline workflows and heighten productivity. The implications of SERA's capabilities are far-reaching. By enabling organizations to train powerful coding agents at minimal cost, SERA paves the way for widespread adoption of AI in software development. This could lead to a significant increase in innovation in repository-level task automation and might encourage fierce competition among AI coding agent providers. As SERA becomes embedded in more workflows, it can potentially reshape developmental timelines and efficiency, although this transformation may bring concerns about job displacement and the ethical implications of automation. Further, the adoption of open-source models like SERA could inspire new directions in coding practices and tool development, setting a precedent for transparency and collaboration in AI research. In summary, AI2's release of SERA heralds a new era in coding automation, facilitating access to sophisticated AI tools with unprecedented financial and practical accessibility. This development is decidedly a step towards democratizing AI technology, streamlining software development processes, and potentially revolutionizing the landscape of code generation and management. Robbyant has strategically open-sourced LingBot World, offering a transformative element to the landscape of embodied AI applications. This cutting-edge, large-scale interactive simulation model is designed to adhere to physical laws, providing a rich, virtual training ground where AI agents can engage in trial-and-error learning at a minimal cost. It opens up new avenues for research and application across various domains, such as autonomous driving and immersive gaming. The model supports up to 10 minutes of continuous, coherent video generation, ensuring robust temporal consistency, and offers real-time interaction at 16 frames per second FPS. This balance between video fidelity and interaction speed is crucial in maintaining realism while enabling dynamic and responsive virtual environments. One of its standout features is its zero-shot generalization capability, allowing the model to extrapolate insights from a single image, thereby enhancing adaptability and reducing the need for extensive datasets. From a technical perspective, LingBot World distinguishes itself through its action-conditioned learning mechanism. This enables the model to understand the impact of actions over time and adapt accordingly, which is vital for creating responsive AI systems. However, achieving optimal performance necessitates the use of high-performance enterprise-grade GPUs, setting a constraint for developers without access to robust computing resources. This requirement highlights a key trade-off between capabilities and accessibility. Accessibility and user empowerment are at the core of Robbyant's open-source approach with LingBot World. developers gain unrestricted access to both the model's code and its weights, fostering an environment ripe for innovation. This democratization of technology enables experimentation with the model's interactive capabilities and zero-shot generalization power, encouraging diverse applications but demanding careful consideration of hardware limitations. LingBot World not only sets a new standard by enabling low-cost trials for embodied intelligence, but also challenges existing models, such as Google Genie 3, which remain closed. This positions Robbyant as a leader in promoting collaborative research and development. As potential collaborators and enthusiasts explore LingBot World, they should consider testing its integration in various simulated settings while preparing for possible challenges, such as environmental drift in dynamic contexts and the high computational demand. In conclusion, by open-sourcing LingBot World, Robbyant pioneers the path toward greater accessibility in AI development, offering tools that promise to enhance training environments and inspire innovations across the AI community. This move could lead to significant strides in areas such as robotics, autonomous systems, and beyond, by providing a robust framework that supports swift iteration and improvement in AI training protocols. However, the model's full potential will only be realized through strategic handling of its inherent limitations and dependencies on high-grade computational infrastructure. NVIDIA is spearheading significant advancements in GPU programming with the introduction of the CUDA tile IR backend integrated into OpenAI's Triton framework. This development is set to revolutionize how developers interact with GPUs by simplifying the process of compiling GPU kernels directly to the CUDA tile intermediate representation (IR). It empowers developers, including those with limited CUDA expertise, to optimize GPU code more efficiently. The decision to incorporate tile-based abstractions marks a substantial shift from traditional GPU programming models such as single instruction, multiple threads (SIMT). By supporting the compilation of Triton code straight to CUDA tile IR, developers can now leverage more granular control over kernel execution. This is facilitated by an innovative ability to switch between PTX and CUDA tile IR backends on a per-kernel basis through the use of the enable tile=1 environment variable. Although specific performance benchmarks are not yet publicly available, the potential improvements in productivity are promising. The integration aims to reduce the complexity of utilizing advanced GPU functions, allowing a broader spectrum of developers to boost their applications. Computational efficiency. However, the current limitation lies in the incomplete support for all Triton operations in the tile IR backend, which may restrict the immediate utility in some design scenarios. A noteworthy characteristic of this technological progression is its dependency on NVIDIA's Blackwell architecture GPUs, such as the GeForce RTX 5080 and CUDA version 13.1 or higher. While this specificity enhances performance potential, it also poses constraints regarding accessibility across various hardware environments. For developers eager to delve into this cutting-edge approach, NVIDIA's technical blog offers comprehensive guidelines on implementing and testing the Triton to tile IR backend. The process involves compiling sample Triton code to CUDA tile IR by utilizing the environmental adjustments detailed in said documentation. Ongoing projects and updates are accessible via GitHub repositories, providing continuous support and innovation insights. The strategic push towards democratizing access to sophisticated GPU capabilities could result in an accelerated timeline for AI model creation driven by increased developer efficiency. The easy-to-use tile-based programming model is poised to optimize resource utilization on GPUs, potentially reducing training durations for complex deep learning tasks significantly. Such advancements might not only foster rapid iterations in machine learning research, but also help reshape the competitive landscape by favoring organizations that swiftly adopt these technologies. This movement reflects a broader trend towards higher-level programming models in GPU development, offering a more approachable entry point for newer or less experienced programmers. Nonetheless, the road ahead is not without its challenges. Balancing the integration's current advantages against its limitations is crucial as NVIDIA continues to refine and expand the backend's capabilities. Future improvements are necessary to bridge gaps in operation support and overall back-end completeness to ensure its long-term viability and success in various applications. Despite these challenges, the potential impact on the field of machine learning and AI is substantial, setting the stage for a more inclusive and effective era of GPU programming. As we've explored today, AI innovations continue to push boundaries across various sectors, whether in threat detection, coding automation, interactive simulations, or GPU programming. Each development not only showcases technological progress, but also highlights ongoing challenges and opportunities. Stay tuned for more insights and breakthroughs in the world of AI.